Welcome to our deep dive into the fascinating world of physics. You know, the universe is always in motion, from the grand dance of galaxies to the frenetic jiggle of atoms. And to understand this cosmic ballet, we need to grasp the language of motion itself, velocity. Today we're exploring the different types of velocity and what makes each one unique. We'll be your cosmic tour guides, navigating through the cosmos of average, instantaneous, uniform, and variable velocities. Buckle up, fellow space explorers, as we embark on a thrilling adventure through the universe's speed limit. Imagine taking a road trip from Delhi to Agra. You might cruise at different speeds, stopping for snacks or scenic views. Your average velocity doesn't care about those pit stops. It just cares about the total distance you traveled and the total time it took. So, if you drove 200 kilometers in 4 hours, your average velocity is 50 kilometers per hour. It's a handy way to summarize your journey, even if you weren't always moving at that exact speed. Now let's say you glance at your speedometer while driving on the Mumbai-Pune Expressway. That reading, my friends, is your instantaneous velocity, your speed and direction at that precise moment. It's like taking a snapshot of your motion. Mathematically, it's the derivative of your position with respect to time, which sounds fancy but just means we're looking at how your position changes over incredibly tiny slivers of time. Imagine a satellite launched by ISRO drifting through the vast emptiness of space, far from any gravitational influences. It moves at a constant speed in a straight line. That, my friends, is uniform velocity. It's the most straightforward type of motion, predictable, constant, and unchanging. Think of it as the cruise control of the cosmos. Now, most things in the universe aren't content with constant motion. Planets orbit stars in elliptical paths, cars navigate winding roads, and even that cup of chai you're holding is subject to the variable velocity of your hand. Anytime the speed or direction changes, you're dealing with variable velocity, the exciting, ever-changing reality of motion in our universe. Imagine the moment a rocket launches from Sriharikota, a sprinter bursts from the starting blocks at the Indian National Games, or a cricket ball is thrown into the air. That very first moment, the velocity at the start of the action, is the initial velocity. It sets the stage for the object's journey, influencing its trajectory and ultimate destination. Final velocity, the finish line of motion. Just like the initial velocity sets the stage, the final velocity marks the culmination of an object's motion. It's the velocity at the end of the time interval we're interested in. The rocket reaching its peak height, the sprinter crossing the finish line, the cricket ball landing back in the fielder's hands. These are all defined by their final velocity. Angular velocity, the spin doctors of the cosmos. Now let's spin things around a bit, literally. Angular velocity describes the rotational motion of objects. Think about a spinning top, a rotating planet, or even a whirling Kathak dancer. It's measured in radians per second, telling us how quickly an object completes a full rotation. The faster the spin, the higher the angular velocity. Linear velocity, straight and to the point. While angular velocity deals with rotations, linear velocity brings us back to straight-line motion. It's the speed and direction of an object moving along a linear path. Think of a car driving down a straight highway, a bullet fired from a gun, or a cheetah sprinting across the Gir forest, all examples of linear velocity in action. Keep exploring the cosmos of motion. Thanks for joining us on this journey through the different types of velocity. We've covered everything from the average speed of a leisurely drive to the mind-boggling spin of celestial objects. Understanding these concepts allows us to decode the language of motion and appreciate the intricate dance of the cosmos. Remember, physics isn't just equations and formulas, it's the story of how our universe moves and grooves. Stay curious and keep exploring the wonders of physics.